Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and we are doing the 24th video for the GCSE revision. It's a video on inequalities. As always, just bear in mind I'm not teaching you the entire topic here. I'll recap the main ideas, but you should go and get extra support from your teacher or on the internet if you want to look or in a book if you want to see more detail, but this is the basic idea. After I've given you the basic idea, you've made notes and you've made a revision card, we're going to try some exam questions. You pause the video, try the question, then play me and mark it against my work. Okay, so inequalities. What are inequalities? Well, inequality is as opposed to inequality, which is an equal sign. They're statements where we don't necessarily have an equal sign. So for example, we might write something like this. We might write 7 is bigger than 2. Okay, that's an inequality sign. It's bigger than. And we've got 4 of them that we need to know. So here's the first one, that one. Here's the next one. The next one is that one. And the last one's this. Now this one, you read it from left to right. And this is bigger than. The bigger side is here, so this sign means bigger than. Obviously then, this must mean smaller than. So smaller than. Or less than. This means bigger or equal to. So bigger, and the line underneath means, or it could be equal to. So bigger or equal to. And therefore this one means less than or equal to. Less than or equal to. Okay, so we've got to know those inequalities there. So say for example I said a statement like x was bigger than 9. X is some number that's certainly bigger than 9. So for example x could be infinitely many things, but x for example could be like 11 or something like that. What if I said x is smaller than 3? X is any number that's smaller than 3, so it could be, for example, 1, although it could be infinitely many things. Now, if I said x was bigger than or equal to 3, well, it could be 3, or it could be any number bigger than 3, or any number bigger than 3, so for example 7 or something. And similarly here, if I said x was less than or equal to 7, it could be 7, but it could be any number smaller than 7, like 2 or something like that. So that's the basic idea. Now let's move on to some of the skills we need for the exam. They will state an inequality and they will ask you to draw it, and they might ask you another question about your drawing. So there are the four questions we're going to go through. Okay, so to start with, the first inequality we're given is that x is bigger than 3, and we're going to be asked to draw it on the number line. So this is the way you do these questions. X is bigger than 3. You mark 3 on your number line with a circle. We want everything bigger than 3, so we do an arrow to the right to indicate we're looking at numbers that side. We do not colour this in because x can't be equal to 3. Now, the extra question they might ask is what's the smallest integer? So what if they ask what's the smallest integer that solves this? Well, it can't be 3. Integer means whole number, by the way. Integer means whole number. So what is the smallest integer x could be? It can't be 3. The smallest one it could possibly be is 4. That's the question they could ask you. Right, let's draw this one. X bigger than or equal to -2. Draw a circle at -2, your key point. You want bigger than or equal to, so you're looking this side here. Now, because it can be equal to, this time you colour in your circle and make it a coloured in circle to show it could be 2 as well as anything to the right of 2. What about S? Here they might ask what's the smallest integer? What's the smallest integer x could be? Integer, remember, means whole number. Now the smallest one x could be is actually -2 because it's a coloured one. So it could be -2 because we've coloured that in. What about this? X less than or equal to 4. Draw a line at 4. Do you colour it in? Yes, because it can equal 4. And this time you want to the left because you want equal 4 or anything less than that. What about x less than -1? Draw a line at -1 and you're looking to the left. You don't colour it in because you don't want it equal to -1. And they could ask you other questions here, like what's the biggest integer that this could be? Well, it could be 4. The biggest thing it could be is 4. What if they ask you what the biggest integer, whole number, that this could be? Well, it would be -2. It can't be -1, and the biggest, it means more right on the number line. Okay, next set of questions, slightly more complicated. So here are 1, 2, 3, 4, 5 inequalities. We're going to be asked to draw them and maybe another question about them. When x is sandwiched in between two inequalities, it means x is between these numbers. So x is between -2 and 4, so draw a circle at -2, draw a circle at 4. It can't be equal to either of those, so you don't colour it in, and you draw a line connecting the two. Done. This one here, draw a circle at -3, a circle at 5, draw a line connecting them, but now it's time to be careful. X can equal 5, so we would colour in this side. X is in between 3 and -4, and it can equal both, so line, circle here, line between them, and both of these can be coloured in. Both of these can be coloured in like that because it can equal -4 and 3. And what about this one? Well, you're going to have a circle at -2, you're going to have your circle at 5, you're going to draw a line between them, and you can colour in the one at -2. Okay, just some, I'll leave the last one at the end. Some questions they could ask. They usually ask this question after they've got you to draw it. List the integers x could be. X could be, when it's one of these in between. Now, it can't be -2, it could be -1, it could be 0, 1, 2, or 3. So 0, 1, 2, or 3. It can't be 4 because it doesn't equal it. What about in this case? Well, it can't be -3. It could be this, or this. So if they asked us to list the integers, we'd list -2, -1, 0, 1, 2, 3, 4, and 5. What about this? Well, this case, because they're coloured in, it can be -4, -3, -2, -1, 0, 1, 2, and 3. What about this one? Well, it can be -2 because it's coloured in here. It can be -1, 0, 1, 2, 3, or 4, but can't be 5 because it's not coloured in here. Sometimes the x isn't sandwiched between. Here this is saying x is less than or equal to -1, so circle at -1. We're going this side like this, and we're colouring that in because it can equal it. Or x bigger than 2. So you draw a line at 2, we're looking to the right, but we don't colour it in. So it could be either of these two things here. Right, so they usually show you one of these. It's usually one of these type. Draw the picture, list the integers. That could be the answer. Sometimes they give you the picture and they ask you to state the inequality. So here, if they ask you to state this, 3 is the key number. You want your x bigger than 3, so it's x bigger than 3. It's not or equal to because it's not coloured in. Right? What about this one? Well, x is sandwiched between two things here. It's between 3 and -4. It can't equal -4, so we're happy with that, but it can equal 3, so you use that symbol like that. Okay, so that's the other way. The last thing with inequalities they can do is get you to solve them. Now, the key idea here came from video 23. They're exactly like solving equations, other than rather than write an equal sign, you write your inequality sign at all times. So let me show you. Here's an equation, here's an inequality. I'm going to show you that solving them is exactly the same. If we solve this equation, we'd subtract 2 off both sides, or bring the -2 there. So 3x would equal 17 subtract 2. 3x would equal 15 then, and we divide by 3. X would equal 15 divided by 3. X would equal 5. Now with inequalities, they ask you to solve them. So it's very like this. They might then ask you to draw your answer on the number line and state the smallest integer value that x could be. So let's write out our inequality. We're solving 3x add 2 is bigger than or equal to 17. Make sure you don't write equals here. Just all you've got to do is the same as you did before, but write your inequality. So you're going to take 2 off both sides. 3x not equal, bigger than or equal to 17 take away 2. 3x bigger than or equal to 15 therefore. Then divide by 3. X bigger than or equal to 15 divided by 3. So the answer is x bigger than or equal to 5. Now they might ask you to draw this. Well, they'll give you a number line. Say that was 0 and that was 5 here. You will draw a circle, you colour it in because it can equal, and you're looking for to the right of that. So you would just draw that on the diagram they gave you. And lastly, it says state the smallest integer value of x that x could be. Well, the smallest x could be is 5, because it could be 5, 6, 7, 8, all the way along. So you might state in this case that x is 5 at the smallest. Something like that. And that's basically everything you need for inequalities. Right, so let's try some exam questions. To start with, so I'll show you a question, pause the video, I'll go through it in 10 seconds. Here we go, starting now. Okay, going through this, I sometimes find that easy to draw a picture, so I'd have a number line, there's 0, -1 would be somewhere like here, and 4 would be here. I draw circles there, a line between them. This one is coloured in, this one is not coloured in, and it says n is an integer, that means a whole number, write down the possible values of n. Well, it could be -1, 0, 1, 2, or 3, but not 4. So -1, 0, 1, 2, or 3, but not 4. Okay, picture usually helps here. A little picture will make sure you get that right. Next question, pause. In 10 seconds I'll go through. Okay, it says draw this on the number line. -3 is my key point, circle there. I'm looking for bigger than, so I draw an arrow to the right. Do I colour in? No, because it's strictly bigger than, it's not bigger or equal to. There's my 2 marks. Solve this. Well, you do it exactly as you would solve an equation, other than you always write your inequality sign. So 7y is less than or equal to 8, add 34. 7y is less than or equal to 42, divide by 7, y is less than or equal to 42 divided by 7, so y less than or equal to 6. You must write y less than or equal to 6, you can't just write 6, it's not an equation. Then it says, write down the integer values of x that satisfy that. I would like to draw a picture just to make sure I don't make a mistake here. Always put in 0, -2 would be somewhere like that, and 3 would be there. Circle at -2, circle at 3, line between them because x is sandwiched between them. You do colour in at -2 because it's bigger than or equal to. You don't colour in here. What integers values can it be? Well, it can be -2, can be -1, can be 0, can be 1, can be 2, can't be 3. So -2, -1, 0, 1, and 2. Done. 6 marks. If that comes up, nice, easy 6 marks. Next one. Pause, have a go. I'll go through in 10 seconds. Okay, it says show the following on the number line. So y is between 2 and -2 and 3, sorry. Line between them, don't colour in that either of them because it's not a less than or equal to sign. There's no equal to, so we're done. Here's an inequality, write it down. Well, x is clearly between 4 and -3, but x can equal 4, so change that sign to a less than or equal to, and we're done. Solve the following, add 5 to both sides, so 4t is 11, add 5, so 4t is bigger than 16, remember to write bigger than, t is therefore bigger than 16 divided by 4, t is bigger than 4. You must write your inequality to get the mark. You must write this sign. If you change it to an equals, you will not get the marks. Okay, next question. Video, I'll go through in 10 seconds. Okay, so It says that n is between -3 and 1. N is an integer. Integer, remember, means whole number. List the possible values. Remember, I always find it best to draw a picture here. Line, put 0 in the middle. -3 would be somewhere over here. 1 would be somewhere here. Circle there, n is between them, like that. You don't colour at -3 because it's bigger than. You do colour at 1 because it's less than or equal to. What integers could it be? Well, n couldn't be -3 because it's not coloured in, but it could be -2, could be -1, could be 0, and could be 1. So the answers are -2, -1, 0, and 1. Then it says solve this. So what you do is you add 7 to both sides. 3p is bigger than 11 plus 7. 3p is bigger than 18. Divide by 3. P bigger than 18 divided by 3. So p bigger than 6. P bigger than 6. You must write your inequality. If you don't get the marks. Next, pause, have a go. I'll go through in 10 seconds. Right, so solve this. So add 7 to both sides. 5x would be less than 28, add 7. Remember to preserve your inequality sign. 5x less than 35. Divide by 5. X less than 35 over 5. And so x is less than 7. You must write that or you will get it wrong. On the number line, represent the solution to part I. So x less than 7, there's actually not enough spaces. There's a small mistake in the exam. It needed to go up to 7 at least. So draw a circle at 7. You want less than, so you're going this side. So you just draw an arrow going that way. You don't colour it in because it's strictly less than. Okay, something maybe we haven't talked about before. N is an integer such that -4 is less than or equal to 2n is less than 3. Write the possible values of n. Well, because we have 2n, we can half everything to make it nice and easy. So divide everything by 2. -2 less than or equal to 1n less than or equal to 3 divided by 2, which is 1.5. Now, if n is an integer, that's whole numbers, what numbers could it be? Little picture's always useful. 0 there, -2 there, and 1.5 there. You know it looks something like this, and it can be equal to this one. What are the integers it could be? Well, it could be -2, it could be -1, it could be 0, or it could be 1, because 1 is actually less than 1.5. So our answers are -2, -1, 0, and 1. Okay, only 2 more questions to go, so pause the video, have a go. Solving this, we add 3 to both sides, so 7x would be bigger than 18, add 3. 7x would therefore be bigger than 21. X would be bigger than 21 divided by 7, which is 3. X bigger than 3. Must write that, not 3, otherwise you don't get the marks. Write down the smallest value of x. If x is a whole number such that this is true, and that's what we solved above, what's the smallest value of x? Let's quickly draw this on the number line. There's 0, 3 would be there, circle would be there, we're looking for bigger than, we can't colour it in. Now if x is an integer, what's the smallest integer x could be? Well, clearly 4 is the smallest whole number that solves this, so we could write 4 there. Last one, we've got 2 inequalities to solve. Pause the video, have a go, I'll go through in 10 seconds. Right, so going through this, we're going to subtract 12 off both sides. So 5x would be less than 17, subtract 12. 5x would be less than 5. Divided by 5, x would be less than 5 divided by 5, which is 1. X less than 1. Don't fall for this trick here. You had to write x less than 1. Now this one had a bracket. First, expand the bracket like you would with an equation, but preserve your inequality. So 6y add 3 would be bigger than 10. Take away 3 off both sides. 6y would be bigger than 10. Subtract 3. So 6y would be bigger than 7. Divide by 6, y would be bigger than 7 over 6. Y bigger than 7 over 6. And we're done there. That's everything for inequalities.